Now we can also look at when c is a fraction, something between 0 and 1. Let's say c is 1/2. So now we have y is equal to the sine of 1/2 x. And for this equation, when we try to plot this using our unit circle, we know it still goes through the origin, since a 0-degree angle would give us the sine of 0, which we know the y value there is 0. When we plug in, let's say, pi over 2, now we get the sine of pi over 4, which we can calculate is root 2 over 2. So let's look at more exact values. Let's look at the sine of pi. This would give us, let's look at an x value of pi. This will give us the sine of pi over 2, which we know is 1, meaning we can plot a point right there. And we'll look at another key point. Let's look at 2 pi. So when we plug in x is 2 pi, the 2's cancel out, we get the sine of pi, which is 0. And what it looks like is that this stretches the function out horizontally. And keep in mind, though, this is comparing it to the sine of 2x. If we go back to our parent function here for the sine of x, when we plugged in pi, we got 1, and at 2 pi, we got 0. Notice we can still see that horizontal stretching there. And it essentially doubles the period. If we follow this all the way out, what we will see is that when it actually comes back up, this would be at 4 pi. So we can conclude that when this c value is 1/2, the period is twice as long compared to the period of our parent function. So the period here would be 4 pi. And in general, when we see that c is a fraction, it's less than 1 but greater than 0, then we get a horizontal stretch. And keep in mind, this is true of function transformations in general. It doesn't have to be the sine or the cosine. We would see these horizontal stretches or squishes when using any function, really. And in the next video, we will look at what happens when this constant c here is a negative number.